Hello and welcome to Moments with Atmosphere in WordPress, the official podcast of International Atmosphere Water Harvesting Association. I'm Amin Mojuri and I'm here today with my colleague Shahnawaz Sinha. Shahnawaz.
Hi, I'm Shahnawaz Sinha. I'm also at ASU. I've been here in ASU for the last 10 years. I'm an associate research professor. My research focused on water treatment. So I'm very much excited about the atmospheric water harvester, and having Chris here is something really, really great.
Thank you, Shahnawaz. We are very happy to welcome our special guest today, Chris Kay, president of WAHA, a company known globally for its work in atmospheric water harvesting, especially in arid region. Chris, thank you for joining us today.
Thanks, Amin. Thanks, Shinawaz. Pleasure to be on the podcast. I'm Chris Kay. I'm the president of WAHA. Been with the company now 5 years. Started my career actually as a software engineer for Hewlett-Packard. Worked for HP for 17 years, and I've been a serial entrepreneur for the last 25 years. Started 8 companies, 2 exits, and Frank Ramirez, the CEO of WAHA, when he joined in early 2020, recruited me and said, "You're going to love this technology, but more importantly, you're going to love the people." And I did, and I do, and I look forward to introducing to you all to the people, but the technology behind WAHA.
Perfect. Let's talk about WAHA. WAHA has made a name for itself in atmospheric water harvesting across the world, especially in Middle East. How did the company get started, and what initial vision drove its creation?
So WAHA, actually officially named Water Harvesting, but we do business as WAHA, which also happens to be just a concatenation of the name, but it also means oasis in Arabic. It was co-founded in 2018 by Professor Omar Yaghi, professor of chemistry at UC Berkeley. Professor Yaghi, Palestinian by birth, grew up in Jordan, knew water shortage. His family was served by a water truck that came around once every 2 weeks. And so being able to provide water was something that was critically important to him. After he moved to the US, got his PhD, he invented the entire field of what's called reticular chemistry, which is a materials science. One of the materials that he invented was something called a metal organic framework, or MOF. This was all started in the early 90s. In the early 2010s, he invented water harvesting MOFs, and then in 2018, co-founded Water Harvesting, now WAHA. Our original mission statement was based on Professor Yaghi's background, was to provide safe drinking water to underserved communities in water-starved areas of the world. This was what all the original people signed up for. This is what I signed up for, something to make a difference in people's lives around the world. And it is a beautiful mission statement, but it's very hard to get funded. So we busy looking for strong economic value propositions. When we started, also, we were an advanced materials company because we had licensed 2 MOFs from UC Berkeley, as well as some water harvesting patents. But we've pivoted from that now. And now we realize that the real value is in the efficient regeneration of not only MOFs, but solid desiccates. So now we call ourselves a solid desiccate regeneration engine company, both traditional and novel desiccants. And so the difference with our engine also is that because we come from water harvesting and we view humidity as an input to making water versus as a waste product, our machine's actually shown that we can be not only an exceptional water harvester, but we can be the world's most efficient desiccant dehumidifier and potentially the most efficient air conditioner as well. And the U.S. Department of Energy Building Technologies Office said that our machine could be the air conditioning answer for 120 million U.S. homes.
Let me talk about what unique regional challenges or opportunities in the Middle East shape WAHA mission in its early days. especially given the dominance of desalination in the region?
Sure. So the Middle East is a perfect market for us, but because it is obviously very arid there, and it's not a lot outside of desalination, which is quite prevalent there. Uh, there's not access to other sources of water, uh, but we're a very small company. Um, so just the distance and time zone changes made it difficult for us. Also, needed to obviously make sure it was a reliable product because we don't have the infrastructure yet to support remote teams providing support. So the machine had to be really reliable. So we worked on that quite a bit. We deployed a system in West Texas first, and which is hot and arid in the summertime and cold and arid in the wintertime. And that was actually for Exxon. And Exxon's message to us was, if you can make water here, kind of like the song New York, New York, if you can make water here, you can make it anywhere. And that's very true. And so now we've shown that our systems are reliable. We've achieved 99.998% reliability with our machines in the UAE and in Sweden. And while desalination is very dominant in the UAE and throughout the Middle East, they're also looking for a more environmentally friendly solution that doesn't have issues with brine, and also doesn't rely on long-term, slow capital projects for distributing the desalinated water. They want to be able to quickly bring up solutions that can support their communities that live in the interior, in the dry sections of their countries. Um, so the other thing is that in the Middle East, and I know the UAE the best, but they import over 90% of their food. And so they really are focused on how they can, this is a national security issue for them. So how can they support traditional agriculture? And that's actually what our machines are in the UAE demonstrating, that we can reliably produce water in any of their seasons, and we can support the needs of traditional agriculture.
Thank you, Chris. That was a great insight into WAHA's story. Now I pass it to Shahnawaz for next part. Shahnawaz?
Hi, Chris. Really, I enjoyed your the way you explained your history and how WAHA was created. Also enjoyed various application area, where you have investigated. My questions are related to that. Already you have discussed of that, but I have got some follow-up questions for you
Sure.
in technology. So my first question is like, how does WAHA's atmospheric water harvester work under, say, for example, three different scenarios? The first scenario is like in Jeddah, Saudi Arabia, it's hot and humid. And the second scenario is like hot and dry, like Phoenix, Arizona. And other one could be cold and dry, like in Denver, Colorado. So what type of operational challenges you may face under these three different geographical locations with a different type of humidity or the heat? And what type of power consumption there would be for those three? Is there any places, where you're gonna consume more power than the last? And the last question is like, how do you distinguish yourself from other refrigerant-based or desiccant-based atmospheric water harvester already in the market? So
Sure.
sorry, it's a long question, but if you could give us some answer, that would be great. Okay.
No problem. I'll try to remember all of those, but let me change the locations to actual locations that we're using. Although I live in Fort Collins, so not too far from Denver, um, and obviously been to Phoenix. But the three scenarios I would use would be Abu Dhabi
Okay.
or hot and humid. You could use Dubai too, but we have a machine running at Khalifa University in Abu Dhabi. We have a machine running in Riyadh, Saudi Arabia, where it's hot and dry. And we have a machine running in Sweden where it's cold and it can be humid, but you can get to some dry conditions as well there also. So uh, I'd say there's two major things. One, and that impacts all three of them. Number one is for the machine, is that There's three air loops in our machine. One is the adsorption loop, where we blow air past our desiccant modules and they pick up water. Well, those are exposed to ambient conditions. So those are going to be the same regardless. But the last two, the desorption air loop and the condensation air loop, all that is done in an enclosed chamber. And this enclosed chamber allows us to maintain the temperatures and humidity levels that we want, regardless of ambient conditions. So we've tested our machine down to minus 20 degrees C and up to 52 degrees C at conditions down below 10% relative humidity and all the way up. And basically, the performance is the same. It's I put an asterisk by that in that there's no magic and we really don't use relative humidity when discussing things internally. We use an esoteric term called mixing ratio, which is grams of water per kilogram of dry air. It's a more precise way to measure it. So when mixing ratio gets low, the only way we can produce our stated amount of water is we have to increase fan speed. So we increase fan speed to present the desiccant with the same amount of water vapor as it would be in an area with high mixing ratio, and therefore we can produce the same amount of water. So that's point number one. Point number two is desiccant selection. As I mentioned, we're desiccant agnostic. So we've tested quite a few number of both novel desiccants, meaning MOFs, and traditional desiccants, silica gel, Sapo 34, others. And so we match the desiccant to the ambient conditions or to the customer requirements. And so if you're in an arid condition, then you'd want to go for a novel desiccant with the isotherm over to the left. With something that's more humid, you can choose a different desiccant. You could choose a different novel desiccant that's more hydrophobic, or you can choose silica gel. And then what are the distinguishing features between our product and others? I think there's 6 things. First is that we create a reliable amount of water across our entire range of operating conditions. So the amount of water we generate does not go up or down if you buy 24 or 200 or 2,000 liter system or anything else. That's what we produce in any conditions. Number 2, it's stable and reliable energy consumption across all those. So again, with the exception of as mixing ratio gets very low, we have to increase fan speed to maintain stable water production. 3, reliability of the machine. When we went to the UAE, they told us your machine better be reliable. The conditions here are really tough. And we've never had an AWG machine that has actually made it in our environment. So we've had machines now running with no unplanned downtime for now closing in on a year. And it's never happened for them. 4th, pure water without any additional filtration. This is really due to a novel desiccant, because you can think of a MOF as a nano separator, and the pore size of the MOF is small enough that large molecules like volatile organic compounds just go right over the MOF. So I tell people you can run it in Colorado during fire season where I live. You can run it in California during fire season where our lab is. You can run it in India or China where it's heavily polluted. And without any additional filtration, you get nothing but pure water. 5th, we have strong economics because of our low energy consumption, our CapEx, not only in water, but in dehumidification and air conditioning as well. And finally, we have a large patent portfolio. We have 14 patent families. We have 19 granted patents around the world, and we're pursuing more all the time. Finally, I think, that's it.
Thank you for sharing all this information. Amazing. You guys have been working on this system feels like from all different angles, and the heart of the desiccant-based system is the desiccant itself, and you have advantage over there. And then you talked about the operational view where you could increase the fan speed to get more water out. So these are really, really interesting. So if I still don't know the internal mechanics of the system, so I have one question related to that, and you could correct me if I'm wrong, So my understanding is that you have developed an innovative desiccant-based atmospheric water harvester with a metal organic framework, MOF, as a desiccant. Probably you've coated this thing on a heat exchanger. Probably you're doing a cooling and a heating with a heat pump in your system using either thermal fluid or refrigerant, which I don't know, with an air condenser, or that could be air condensed, or it could be refrigerant-based condenser. And so if you could, I don't want any confidential information to be disclosed, but if you could give us some idea as the water comes,
Sure,
what is happening in your system, that would be great.
sure, happy to. And I can describe it in some level of detail because the patents are not only published. Our key heat pump-based patent is not only published, but is being granted in several countries around the world already. Um, so while we have 14 patents, the core one is, as I mentioned, is our heat pump-based patent. And what's unique about that is we balance desorption and condensation energy with the heat pump. And we've invented no new mechanical parts. So we just use off the shelf, basically refrigeration system components, whether it be heat pump or heat exchangers or fans or things like that. But it's the design is very unique. And it's putting all of that in, putting the desorption and condensation air loops, which I described earlier, in a sealed chamber. Uh, the desorption loop tied to the uh, condenser and the condensation chamber tied to the evaporator. And because we again view water as an input or humidity as input to making water versus a waste product, again thinking about it as a dehumidifier or input to an air conditioner, we can we can tune the temperatures of the condenser and the evaporator. We can substantially improve the COP of a heat pump, and we do. So that's what leads us, that's what gives us the overall energy, or that's the primary energy efficiency. And it enables us to then, again, because it's in a sealed chamber, run anywhere in the world, with the exceptions of Greenland and Antarctica. We can reliably run our system any place else. Uh, so that's it basically. We don't no we don't use coat material on a heat exchanger. We actually have developed our own uh, methods for making a desiccant module. And so the idea is to minimize the thermal mass of the desiccant module so it's quick to heat up and quick to release water. Takes as little energy as possible to do that so we can get the water out there and then condense it and then move on to the next.
That's very interesting. So you're saying like if you have a different type of desiccant, the regeneration temperature could also be varied based on what the regeneration temperature would be. You could also manipulate that.
We can, and we do. So, and it's also then we can adjust all that based on what the customer's requirements are for either more energy efficiency or more water generation, things like that. So we can do all of that.
Okay, great. I will, Amin, then you have a few more questions for
Y-
Chris, and I will come back again, Chris, to you.
Yeah.
Okay.
Now talk about deployment and partnership. WAHA has been involved in several high impact projects. Could you share a key deployment and its local impact?
Sure. So we are still early, but I'll reference two. So the first one is quickly. I'll reference two. One is for Taka. TAQA. They're one of the largest utility. They're the largest utility in the Middle East and one of the largest in the world. Um, so we are doing a project for them. That's the one I referenced earlier to support traditional agriculture. Khalifa University in Abu Dhabi is managing that project, and that project is being funded by ADQ, which is the Abu Dhabi Sovereign Wealth Fund. Um, so again, we have two machines they're running now. They've been extremely reliable. One in Abu Dhabi, another one at a desert site to show that we can run in both humid environment, hot and humid, as well as hot and dry environments. Um, they shared with us what their selection criteria was, and they said that they used an industry consultant to identify 140 different AWH companies. They narrowed the list down to 13 finalists, interviewed all the finalists, and they selected one for their project drop. Our ability to handle, again, conditions in the Middle East. So that's going well. We hope to be completing phase 2 of the project and then have our machine out at a farm in fourth quarter. So the next one actually is very unique, and we thought actually this customer was crazy when he came to us originally, but the customer is Lean Dry out of Sweden, and he had actually listened to Professor Yagi giving talks about moths while he was out. He's an organic farmer, um, and he thought that our technology could be used for grain drying. And again, we didn't think much of it, but he kept pursuing us, and we did the math, and actually, it really works. In that, what he wanted was something to reduce grain drying time and also to dry grain with no added heat. So, because our system, again, AWH machines produce two outputs, pure water and dry air. And so, if we dry the air without imparting any additional heat, then we can dry the grain and keep the quality of the grain. Because when you use natural gas or resistive heating dryers to dry grain, you can damage the grain if you heat it too much. So this is a way we can both dry it faster, so we can cycle through more grain at one time, and then also we can keep the quality up.
You already pointed out previously, but let me ask it again clearly. How have partnership, whether with governments, university, or private industries, influenced WAHA ability to scale and deliver solutions?
So universities, we've worked with 4 universities so far. Hopefully, we want to add ASU here soon.
Yeah, sure.
But obviously, the first one is University of California, Berkeley, where not only our visionary founder, Professor Yagi, came from, but also our 2 lead technologists, Eugene Kapustin, our CTO, and David Kuo, our EVP of engineering. Then we've worked for several years with OST out of Switzerland, East Swiss University. I can't pronounce it but they have a high temperature heat pump lab, and we've been working with them to optimize performance of our heat pump system. Khalifa University, been a great relationship there. They've been managing the implementation of our machines in the UAE, and we're working with them also on another. We had a press release a couple months ago about a novel desiccant that they've invented that we're working on to test in our machine. And finally, University of California at Davis as well. They have a test vertical farm chamber, and they're going to be testing our machine and its ability to provide superior dehumidification for our vertical farming. For industry, I'd say the main category is with large chemical companies who have been working with us on MOF synthesis and MOF coating. First one primarily being Mitsui Kinzoku, part of the Mitsui Keiretsu. Mitsui Kinzoku has made our MOF 303 for us. other MOFs for us. They also make, pardon me, lithium-ion batteries, and they they were convinced that our machine could help them save money in the manufacture of lithium-ion batteries, and they paid for a pilot machine for us to prove this hypothesis, and we did, and we were able to show them that we could save 40 to 60% on dry room air conditioning energy costs for lithium-ion battery plants. And they told us that this would equate to 15 points of margin for them. Now, I've told this to many people. I heard it from the executive officer reports to the CEO. I don't believe it, but the math does back that claim up, because dry room air conditioning is the most expensive OpEx component of making a lithium-ion battery. And then there's BASF, who also has made MOFs for a long time. And then government, the U.S. Department of Energy Building Technologies Office and Lawrence Berkeley National Labs, together with both of them, we've signed what's called a CRADA, Collaborative Research and Development Agreement. And this is to take our water harvester and to make it into an air conditioner. So they are going to help us optimize. We've already started. They're helping us optimize performance of our machine. They're doing a product market fit to identify the ideal AC segment of the market that we should attack first. And then they're going to be working with us on writing regulations to help move the industry towards AC equipment based on our technology. We've also worked with NREL and NAWI, the National Alliance for Water Innovation.
Wonderful, thank you. Yes, the partnership is so important for emerging technologies. Let's go back to Shahnawaz for our final section. Shahnawaz?
Chris, I'm very impressed. Like you said, you're a small company, but the activity that I listen to, my God, a lot of stuff are happening. So you must have a very efficient team engaging with so many entities, making your system more efficient and robust. So congratulations on that.
Thank you.
I have like two more questions. This is about the vision and the future outlook. So my first question is like, atmospheric water harvesting is still significantly energy intensive if you compare it with the conventional or the seawater desalination, and MOF is also pretty expensive, if I'm not wrong. So my question is like, how do you envision atmospheric water harvester acceptance and its role in the international and the regional strategies for water security and climate changes, knowing all these challenges that we have?
Yeah, great questions. So clearly, I mean, this is actually one of the reasons that drove us to being desiccant agnostic, because we licensed two great MOFs from UC Berkeley. Very expensive. Now, we've driven, in the 5 years I've been here, we've driven the cost of those MOFs down by well over an order of magnitude, but they're still expensive. So we're working on driving them down much further. Now, there are MOFs that we can make now that nothing's gonna beat out silica gel, but we have MOFs now that will fit into a capex or a cost of goods sold that enable us to deliver a competitive machine. So I think that's the first thing. The second thing is that because, again, we've invented no mechanical parts. We just use off-the-shelf mechanical parts. We can rely on all the innovation that's going on in heat pumps, things like that. So those, both the cost and is going down and performance is going up. So it's those two things together, and as well as obviously continuing to improve the reliability of our machine. So I've already said that we're closing in on 5 nines of reliability, and that reduces the amount of local support, things like that we need for the machine. So all those things together, we can show a a roadmap or a glide path where we can reduce our levelized cost of water down to something that's, well, generation to generation, just looking at generation capabilities, you won't ever be able to, I think, equal desal. But if you combine in uh, generation and distribution costs, I think it will be a competitive solution. But I also think that uh, using using these systems to uh, uh, enable you to basically, I look at our systems, AWG systems or AWH systems, sorry, as like comparing with a cell phone versus a central office phone. Is that you can you can start these systems up basically anywhere and generate water, and by combining them together like a server farm and managing them as such, you can provide equal or better reliability than you can even with a large centralized plant. So I think once we continue to drive down the cost and improve reliability and show that we can not only scale up just in size, but then be able to manage broad implementations and be able to have hot swapping and always on demand services. I think there's actually not just cost, but other benefits to AWH in a utility or an industry or government provision of water to local populations.
So this is very encouraging. You're saying like you're still continuously developing new types of MOF that would bring more efficiency and the cost would be could be reduced. And this is like a continuous mission that you have from your side.
Well, we well Eugene Kapustin, our CTO, has two PhDs in chemistry, including one from Professor Yagi. We are not actually developing our own MOFs anymore. Even though he's one of the leading experts on MOF in the world. We are working with many others, both research organizations and large chemical companies on new materials, new desiccants. Like I mentioned, that we were working with Khalifa University on a novel desiccant that they had developed so that we can put it into our machine because there's lots of great research done, as you guys know from the summit, research done on novel desiccants. And we look to work for all of them because they will have their best performance in our desiccant regeneration engine because we'll be able to optimize the performance of whatever novel desiccant that would be in whatever customer situation would be through our engine.
So Chris, I have like a last question. I think you already addressed it in a different ways, but the question was more like, what does success look like for WAHA in the next 5 years, both in terms of innovation, geographic expansion? Is it on material development, process, or energy innovation, or adaptation to a centralized, decentralized community or household-based application? So what is your target for the next 5 years?
We've spent quite a lot of time developing the technology, as I've already gone through, and patenting that technology and proving that technology. Now it's time to deliver. So it's to get the product out to market. And in the next couple of months, you will hopefully see or read about a number of partnerships that we'll be announcing and machines available. So that's point number one. Um, so then we're going to scale our portfolio, continue to scale our portfolio both up and down, because people want to talk about much bigger machines. Our machines have been relatively small up to now, but the physics of making water in arid regions or cold is very challenging. And now that we've, I'd say, largely figured that out, of course, we'll be improving on that for the rest of our lives. But we've now proven that it works and it's reliable. Uh, Now it's time to get that out and deliver value into the marketplace.
Thank you,
And
Chris.
then and then finally, it's to scale from not only AWH, but then dehumidification. So I expect both of those to happen within the 5 years, and that we then be significantly down the road to delivering an air conditioning solution as well.
So a lot of great promises, like an application-wise, so many different places it could be utilized. So it was a very good conversation with you, and I learned a lot. So I
Thank
will
you.
hand you to Amin again.
Thank you again, Chris, for this inspiring, actually, conversation. Before we
Thank
wrap
you.
up, is there anything else you would like to add or share with our, listener?
Well, I think the future is very bright for AWH, for the AWH market. I think that there's lots of opportunities out there for not only WAHA but for other providers. I think that again, as we meet the challenges that I've outlined earlier, that I think the market will grow, the acceptance will grow, the opportunities will increase, and we look forward to that, and we look forward to being a big player in that and working with the uh, yeah with the with the team at ASU and others to build the market.
Okay, that was a very exciting conversation. Thank you very much. And thank you to our listener. And I hope you subscribe our YouTube channel and see you in our next episode. Thank you.